So now we'll be going over the Maguire et al. Study in 2000 into taxi drivers and hippocampal volume. This is one of the biological studies in the biological area. It is actually the last of those studies, and it is the modern counterpart to Blakemore and Cooper when it comes to looking at brain development and plasticity. Now, they looked at it in cats. Maguire here looked at it in humans. We'll get into that now. For the context, the role of the hippocampus in navigation. It forms sort of like a cognitive map or mental representation of spatial relationships. So where you are in relation to everything else, and if you had more experience in that area and you saw a change in volume in the hippocampus, it would suggest brain plasticity, which is what we're trying to find evidence for here. The idea that your brain can grow and develop, and certain parts will grow or shrink depending on usage. So the aim of this study is to investigate if there was a difference in the hippocampal volume between individuals who did or did not have extensive navigational experience. So what we'll see is that will fall into people who were taxi drivers, who you would expect to have a good amount of navigational experience as they're doing different routes every day, especially in the same city, and people who may not have that sort of experience. So with the method, it was a lab setting. It's a quasar experiment. The IV is naturally occurring. The researcher cannot determine which group the participants go in because that's already determined by their jobs. They have to go in either the taxi driving or non-taxi driving group. A correlational analysis was conducted between hippocampal volume and time spent as a taxi driver, which if you weren't a taxi driver would be 0, and if you are, the other years would influence that. So it's a correlation, which means they're not actually carrying out any experiment. They're not getting these taxi drivers to do any particular task. They are just gathering information, and then they're going to be comparing that. So the group of taxi drivers were 16 right-handed males with a mean age of 44 years. It's not that many, but MRI scans can be quite difficult to get a hold of. Use can be a bit expensive. It's quite good for that. And their experiences of driving had a mean age of 14.3 years, although that could vary quite a lot. Training takes about 2 years on average for a taxi driver, and they were all neurologically and psychologically healthy. So all neurotypical, all standardized, male, right-handed. Only difference would be the amount of time that they had spent being a taxi driver. The control group was the exact same. There were no females. There were no people that were left-handed. There was no one under 32-year-olds or over 62, as that was the range that you had with the taxi drivers, and no one with any physical or mental health issues. This came to 50 individuals with MRI image scans. Now it's important to recognize that these image scans, were pre-done. They did not do that for the purpose of this study. They found MRI scans who fit into the demographic that they were interested in, and they used that to compare the taxi drivers to. So, procedure, it's independent measures. It has to be independent variable being whether it's a taxi or non-taxi driver, and the dependent variable being the volume of the hippocampus on the left or right side. To test via MRI scans, all done by one experienced individual who was blind to the participants' condition. They did not know if they were a taxi driver or a non-taxi driver. Always the same guy, very standardized, no room for interpretation between researchers there. Pixel counting was used to compare the 16 taxi drivers to 16 precisely matched controls. So out of those 50 individuals that they had brain scans from, they took the ones that were closest in comparison to the taxi drivers and compared it to them. This was then, the amount of pixels was then converted to an overall volume for a more accurate comparison, and only one participant had to be excluded just due to how much longer he'd been driving compared to the others, and it just would have skewed the results a little bit. So your overall participant level is actually 15 participants rather than 16 because one had to drop out. So results, it's all quantitative data, all just volume effectively, and the only significant difference was between the left and right hippocampi. The difference was significant for left and right posterior hippocampi, but not the anterior. So that's the back rather than the front. Statistical analysis showed significance. more grey matter in the taxi drivers, in this posterior hippocampus that we're on about. The controls actually had a greater anterior hippocampal volume, and taxi drivers with the greater posterior, as we've just mentioned. So there is definitely a significant difference in the brain volume based on that occupation. The correlation was found between time spent as a taxi driver and the right posterior hippocampal volume, not specifically the left, but the longer you were a taxi driver, the larger your right posterior hippocampal volume was. So they concluded that the distribution of grey matter in the hippocampus changes with use. The posterior hippocampus appears to store spatial information about the environment and grows when used more. So they looked at the whole brain and any differences, and the key difference they saw was in that posterior hippocampal volume, indicating that not only was this used to store spatial information, because that was the main difference between the control group and the taxi drivers, but also that as they used this area of their brain, it began to grow larger, whilst the anterior shrunk a little bit due to less usage. Taxi drivers add to their navigational maps over time, and the posterior of the hippocampus changed in volume. So that's what they found, effectively. That's what they concluded. As you use that bit of the brain, it can either grow or shrink depending on usage, which is good evidence for brain plasticity. So to evaluate the study, lab experiment, very highly controlled variables, very standardized, extraneous variables eliminated by matching those participants so well. And all this does is that for a correlation, what you want to do is establish a thing called causation, where effectively you want to be certain that your independent variable is the thing causing the dependent variable to change. So when it's not that controlled, you can't necessarily isolate the impact of the independent variable like that. But because they've got it so controlled, it's very likely that it was the fact that they were taxi drivers and that they had this greater wealth of spatial information that had caused that difference in brain volume. It's quantitative data, which is good here. It allows you to perform a statistical analysis, and it stops any bias from occurring because you can't really argue with the numbers. Informed consent was gained, including the risks of using an MRI machine, which can come if you're claustrophobic, if you've got any sort of metal anywhere, be it a tooth or certain inks and tattoos, although they wouldn't have let you do it if you had that. And their sample also sort of excluded any other dangers. So people who are quite physically frail or pregnant women are not allowed or shouldn't be using MRI machines, and the size of the sample and the demographic of the sample sort of stop that from being an issue anyway. Ecological validity is not an issue because they're not having them perform any test. They're just analyzing their brain volume, so it doesn't have to be applicable to real life. And it was a large sample. It's only 15 participants, which is low, but for an MRI scanner to be used, it's quite difficult, quite expensive, and for this type of study, that is a large sample, and the spread of it was quite good for this type of study. So even though it's low objectively, it suits what they were going for. In terms of negatives, there are a few, not too many. It's quite a good study overall. The occupations and interests of the control group were not measured. They didn't have access to it because these scans were pre-recorded, which is a bit of an issue. You don't know if necessarily one of your controls was also a taxi driver or a lorry driver, perhaps, or had any sort of other job which could limit or increase the amount of spatial information that they had in their head. And with a lower sample like this, that could become more of an issue. Replication could involve different interpretations. They only had one researcher performing that analysis each time. So if you had someone else, they could have come to different conclusions. When it's done in the future, it won't be that same person. They could analyze it slightly differently, see the data a bit differently. Always a slight issue with replication when you've got different researchers performing it. And the fact that it was only male right-handers that were used. It was good that they matched that to their MRI scans, but you now still don't know if these results that they found of the changing in hippocampal volume was unique to male right-handers. It could be different with people with left hands. It could be different for women. They don't know because they didn't research it. So in terms of the application of the study, practically, understanding plasticity is important for rehabilitating people with brain damage. If you understand that with use, parts of the brain can regrow and can grow larger and change over time. That is very useful for then devising treatment in the future. It could be useful for stuff like diagnosis and treatment of Alzheimer's if you follow that research further, in terms of localization of function, because they've managed to find that the hippocampus is responsible for this spatial information. So you have localized function in the brain, which is very useful to know which bit of it does what. Um, and that whole basic principle of that if the hippocampus can change how it's built and its size, then other areas in the brain are likely to be able to do the same, which is then useful for devising those treatments. So overall, I think Maguire is quite a nice study. It's quite short because it's a correlation. Um, Nice and scientific, of a sorry, classic example of a lab study, quite deterministic based on the job, no other impact, quite reductionist actually. Ignore the determinism. It's very reductionist. It's purely saying that your occupation and the amount of spatial information you have is going to cause this change. Very reductionist. Um, and it is nurture. Anything with brain plasticity and this development is going to be nurture, despite it being in the biological area, which I think is quite interesting because it's saying that it's as a result of your experiences that your brain is changing its wiring this way. So, despite us typically thinking of it being nature in the biological area, I tell you what, it could be argued that it's both, because your brain structure is inherent and it's nature based and it could be influenced by genetics. But this is precisely saying that your use of your brain throughout your life is going to indicate how it changes, which, in my opinion, is fairly nurture. So it could be a good example there if you argue it correctly. So yeah, hopefully that was helpful. Quite a simple one, this one. Still can slip your mind a little bit because of how simple it is. So yeah, hope that was helpful.